So I received a question from one of your fellow students about this question, 13.1, number 23, and I decided, that is such a good question. I would like to cover it with you. So let's see, researchers wanted to determine the psychological profile of healthy children was different for children suffering from recurrent abdominal pain or recurring headaches. A total of 210 children and adolescents were studied, and the psychological profiles were graded according to the Child Behavior Checklist, CBCL. Children were stratified into two groups, 4 to 11 and 12 to 18. The results are in this table, so I click on the icon. And there's the table. You can see there's the control group had 70, the RAP, which was the recurrent abdominal pains right there. There were 70 of them, and then the headache. So I can copy this. I could open it in StatCrunch. That's an option as well. Although StatCrunch really isn't going to be very helpful. Or I could just copy it to the clipboard. That's another option. Or I could put it in StatCrunch and then copy it to the clipboard. Whatever. All right, so let me get StatCrunch open, or excuse me, Excel open, and here it is. Oops, I was working on a different one. So I just pasted those in. Everything's grand. Wonderful. Okay, so the first thing it wants to know is what is the standard deviation? Oops, I'm gonna put these side by side here. Hold on, just so you can see them both. Okay. Compute the sample standard deviation for each group. Well, we have the variances right here. So remember, the sample standard deviation would be equal to the square root SQRT of that value. And then I'll just drag it down. There we go. Okay, so they want the nearest tenth. So that's going to be 4.6 for this one. And then for the next group, 3.6. And for the next group, 2.9. All right. What sampling method was used for each treatment group and why? Well, it tells us right in the problem that, let me see if I can find it, children were stratified in two age groups, right? So stratified. Wonderful. All right, now we're going to use a two-sample t-test for independent groups to determine if there's a significant difference in the mean CBCL scores between the control group and the RAP group. Assume that both are simple random samples. Use alpha equals 0.05. Okay. So at this point, I'd like to remind everybody that we had notes for independent samples. That was section 11.2, if I'm not mistaken. So I'm going to scroll to 11.2. There it is. Okay, so we're going to be testing the difference in means for two independent samples, assuming they're independent. And we only want to know if they're different from each other. We don't really care about a direction. So it's going to be a two-tailed test. All right, so let's go over here. And I'm only interested in, I think it was the control group. And let me see. Yeah, the CBCL and the RAP group. Okay, so the CBCL, oh, sorry, I meant it wrong. Difference in the CBCL score for control and RAP. All right, so I'll do it over here, part C. So step 1, we're going to assume that mu, oopsie, you know what, I'm going to just paste that in there. Hold on. There we go. All right, so there's my null and alternative hypotheses. Okay, step 2, they gave us an alpha, which was equal to 0.05. Okay. Step 3, let's see what we're going to do next. Find our test statistic, which is this big guy right there. So I'm just going to put him in here for my own sanity. All right, so we got to find that. That's equal to, all right, we want to find the difference in the sample means. So I want to take the difference in the control group and the RAP group, right? So if I take this guy minus, oops, sorry, C2, there it is. I screwed that up. There, that one minus that one, close parentheses, close parentheses, that's the end of my numerator. Actually, I didn't need both sets of parentheses. Yes, I know. Hold on. There we go. So I got to take that difference, close my parentheses, then divide it by the SQRT, the square root of D2 divided by N2, or B2 plus D3 divided by B3, right? That's that formula right there. There we go.